There is no frequency domain analysis in this topic. For frequency domain analysis, we go to separate topic that will be called a frequency domain analysis of signal, in which we will study Fourier series, Fourier transform, etc. Okay. So to define a signal, what is a signal? Mathematically, I can say it is a physical quantity that varies with respect to time, frequency, and space. When I say time, frequency, and space, if I take any example of signal, let's take xt equals to a sin omega t plus phi is the phase, omega is the frequency, t is the time, a is the amplitude. This corresponds to space, frequency, time. Okay. So anything can change, either space can change, frequency can change, time can change. So this a physical, it can become any physical quantity. This type of signals are, they have, in this, if I vary only time, remaining things are constant, then they are one-dimensional signals. Okay. Only one independent variable. Next, another category in which there are two independent variables, that will called an image. Like equation of circle, square plus there are two independent variables. Hence it is two-dimensional. Third category among this will be a three-dimensional signal, that will be called a movie. Or I can say here, an image has got one more independent variable with respect to time, then it becomes a moving image, or it can be called a movie. Okay. It will be a function of x, y, and z. Z can be variable with respect to time. Independent, three independent variables. Three-dimensional. In our topic of signals, we study only one-dimensional signal and their frequency analysis. Okay. Now, if we see for the different types of signals and different classification of signals, we will find these things. If I say different types of signals, I can say that there are only four types. First is continuous time Second is continuous time non-periodic. Third is discrete time periodic. Fourth is discrete time non-periodic. So there are four different categories: continuous time, discrete time, periodic and non-periodic signal. Now this is regarding the types of signal. Now if I want to classify the signal, then I will say there can be an infinite number of ways possible for classifying a signal. Okay, but here we will see about 7 major categories for classification of signals. We will list out the first one is continuous, discrete and digital. The next one is random and deterministic signal. Third one is periodic and aperiodic signal. Fourth is symmetric and antisymmetric. Real and imaginary signal. Fifth one. Power and energy signal. Seventh is causal and non-causal signal. Okay. Now we will take one by one. We will study what each classification is about. The first one is continuous, discrete and digital. If a signal is continuous with respect to x-axis and y-axis, see, I'll plot a signal on two-dimensional plane. I'll plot a one-dimensional signal on two-dimensional plane. I have here time, I have here amplitude. This is my x-axis, this is my y-axis. Now, if signal is continuous with respect to x-axis and y-axis, then It is called continuous signal. Okay. Now it may happen that x-axis may discretize. Discretize means it has got different points on it, and y-axis is continuous. Then signal is called discrete signal. It means I can write if x-axis is discretized and y-axis is continuous, then the signal is called discrete signal. I can write here, I plot this. I can mark the various points on this. On x-axis it can take any value. Okay, but on x-axis it can take only finite values like n, but on y-axis it can take any value with any real number. Okay, now we have seen for discrete signal also. Now what is a digital signal? Now when we quantize this discrete signal to certain levels, it becomes a digital signal. That means I can say if x-axis as well as y-axis both are discretized, then signal become digital signal. Now converting this quantized value to some binary format will give me the digital value of that. Okay, but the real definition goes with when both the axes are discretized, then I'll call a signal as digital signal. Okay. Second will be random and deterministic signal. If there exists uncertainty in signal with respect to time, then it is called a random signal. Okay. Mathematical representation for random signal is not possible. Okay, so we go by the statistical method for evaluating the random signals. Oppositely, if there exists a certainty in a signal, then it becomes a deterministic signal. So I can write otherwise it is deterministic. Okay. Now third category is periodic and non-periodic signal. very important, and we should know how to find the period of the signal. Okay, so mathematically it is defined as, okay, we will take the separate cases. We will take first the case of non-periodic. We'll take the first case for period for continuous time signal, and then we'll go for the discrete time signal. For continuous time, if a signal satisfies this condition, then it becomes a periodic signal with period equal to t. Okay, simple. If this condition is satisfied, period becomes t. This period t is called a fundamental period, because if any signal satisfying the above condition, then this also satisfies x of t plus 2t. But we always talk about the fundamental period. First, amplitude and phase have no relation with period. Okay. If I want to find the period of sine 2 pi by 5t, then this is equal to 2 pi upon 2 pi by 5 is equal to 5. Okay. Thus we have to divide the coefficient of t by 2 pi. Divide the coefficient of t with respect to 2 pi. Okay. Now suppose there are two signals, x1t with period t1, x2t with period t2. Then period of x1t plus minus x2t will be, there is a method to find the period of this. Let the period be t. This t is equal to mt1 or this is equal to nt2. Okay, I can write m by n is equal to t2 by t1, and this should be equal to some rational number. If this comes out to be an irrational number, that means it is not a non-periodic. It should be a rational number. So I can, from this I can make out two things. Write as a point number 4. Two periodic signal, if they are added, then there is a possibility that the overall signal may not be periodic. Okay, one periodic plus one non-periodic, it is definitely going to be a non-periodic. If both are non-periodic, definitely it is a non-periodic signal. Okay, so this was case for the continuous time. We will see now for discrete time. Okay, for finding the period for discrete time signal, the general formula is omega naught by 2 pi is equal to k by capital N, where k is any constant, N is a period. Okay. Example, sine 2 pi by 5 N. Period of this will be 2 pi by 5 divided by 2 pi equal to k by N. This is equal to 1 by 5. This implies that N is equal to 5. Okay. The period in this case is 5. Take another example. Xn equals to sine 4 pi by 3 N. In this case, I can write 4 pi by 3 into 2 pi is equal to k by N. This implies that 2 by 3 is equal to k by N. This implies that N equal to 3. Thus the period in this case is 3. Okay. Understood how to find the period? The ratio of k by N should always be a rational number. If it is not a rational number, that means it is not a periodic. Note. If there are two discrete time signal x1n plus minus x2n with period n1 of this and with period n2 of this, then overall period LCM of n1 n2. Okay. Just remember how to find the period. We have to take the LCM when we are in discrete time domain. Next category will be symmetric and anti-symmetric signals. If a signal satisfies this relationship xt equals to x of minus t, then it is a symmetric signal. Also called it as a even signal. And when signal does not satisfy this relation, it becomes x of minus t, then it called an odd signal. Okay, it is also called anti-symmetric signal. Okay, so we can express any signal as a sum of even signal plus an odd signal. I can write xt equals to xet plus xot, where this is symmetric part or even part, this is odd part or anti-symmetric part. Okay, I can write x of minus t is xc of minus t plus x odd of minus t. Then x of minus t will become xet minus x not t. Okay, let this be equation number 1. Let this be equation number 2. Solving 1 and 2, I can write xet is equal to 1 by 2 times of xt plus x of minus t. xot is equal to 1 by 2 times of xt minus x of minus t. Okay. This is we can find out the even part and odd part for any signal using this relationship. Next category will be, next classification is real and imaginary signals. Okay. If a signal satisfies the following equation, xt equal to x star conjugate, x conjugate t, that means it will become a real signal. Otherwise, you can write here, then real signal. If a signal satisfies this relation, then imaginary signal. Okay. So on these two conditions we defined a real and imaginary signal. But how to draw an imaginary signal practically? Okay, we actually cannot draw an imaginary signal practically, but in case if xt is a complex signal type e to the power xt equal to e to the power j omega naught t, then it is nothing but cos omega naught t plus j sin omega naught t. So cos omega naught t is the real part and sin omega naught t is the imaginary part of the signal, but not the imaginary signal. It is a imaginary part of that. Okay, remember this. Sixth category classification is power and energy signal. Very important. Just try to understand this. See, if I take a periodic signal exists from minus infinity to plus infinity. That means if I integrate this periodic signal from minus infinity to plus infinity, definitely I am going to get an infinite energy. But there should be a finite energy power. Okay, so the signal xt is said to be power signal if energy is infinity but power is finite. I can write periodic signals are power signals. Okay. Second, looking for the energy signal. Okay, before that I'll write the formula for power signal. You can write P equals to limit t tending to infinity 1 by t minus t by 2 to t by 2 xt square dt. Now for energy signal I can write a signal xt is said to be energy signal if energy is finite and power is 0. Non-periodic signals are energy signals. So what will happen in non-periodic signal? The period t in non-periodic signal is infinite. So when I want to integrate this for period 1 by t, it becomes 0. Okay. Power in a non-periodic signal is 0. Energy is finite. Remember this. In discrete time domain, I can write P equals to limit n tending to infinity 1 by 2n plus 1 summation n tending to minus n to plus n xn whole square. Energy can be written as summation n tending to minus infinity to plus infinity xn square. Okay. So till here we have seen the different types and different classification of the signals. We will also see the problems related to period, symmetric, even, odd and power energy signal also. Okay, in the upcoming topics.